Today's video is going to cover analyzing features of quadratics. This is lesson 5.6. The goal today will be to identify key features of a quadratic, like the max or the min point, the linear term b, and the constant term c. So let's go ahead and define what those mean. So with quadratics, you'll either have a quadratic that has a maximum value or a minimum value. Maximum value, you can tell when the quadratic is opening down. The highest point is the most maximum point, and this point actually has a name for quadratics. We call this point the vertex. This is the vertex of the quadratic. So if the vertex is a maximum, then the quadratic is a maximum value. If the vertex is a minimum, the vertex is the lowest point on the line, then the quadratic is a minimum value, meaning it opens up. So we'll use these two examples to kind of identify whether the value is maximum or minimum. Now, if you weren't able to see the quadratic, another way of telling if it is a minimum value or if it's going to open down or if it's going to open up is the coefficient in front of the x squared term. So they use this a to represent the number in front of x squared. Normally we don't see a number because the number is 1. But if there is a number, if a is less than 0, then we know it's going to be a maximum value because negative numbers make it open down. So if you had like some negative in front of the x squared term, then it would be a maximum value. It would open down. If you had a positive in front of the x squared term, so just a 1, then it's going to open up. So if a is greater than 0, then it's going to be a minimum value. Let's get into a couple examples today. So our main goal today will be to answer these 4 questions down here. So let me go ahead and read the question, and then I'll take you through the steps as we go through this problem. So it says, a student launched a rocket into the sky. The table below shows the time since the rocket was launched in seconds and the height of the rocket in feet. So our two quantities here are time and height, which we can obviously convert to x and y if we want. We know that x is always going to be time, and we know that y is always going to be height, so we can change those out if we want to, if we feel more comfortable with that. And we've got to figure out, does the function have a maximum or a minimum value? And then we've got to figure out what the b value is for the quadratic, and it says that the student is trying to fill in the function rule, and so far what he's come up with is the coefficient in front of the squared term, which you can already see is a negative, so you're probably thinking, okay, it's got to be a maximum because it's opening down. Then we'll find the c value, and then we'll answer this last question. If the rocket did not get caught in the tree, did it hit before or after 6 seconds? So if you think about your rocket, as you launch it up into the sky, it's going to go up some distance, it's going to hit its vertex, and then it's going to begin to come back down to the ground. So the ground is obviously right here, and we're trying to figure out, is this time at which it hits the ground 6 seconds, or is it a little bit before, or is it a little bit afterwards? So let's do the first part, and the first part is to figure out what b and c are. So we're going to find b and c, and very easy using the graphing calculator. So I'm going to go ahead and pull up the graphing calculator, and I'm going to go to the regression feature. So you can see when you pull up the graphing calculator, you're going to go to the regression, and then you can see that we have a table right here, and I'm going to input the table that is given to us into this table. So I'm going to pause the video, I'm going to input it, and then we'll check to make sure I inputted it correctly. So what I've done is I've clicked on each of these boxes, and I've put in the table exactly as it was given to me, except the first value is wrong. The first value should actually be 8. Let me type in an 8 here. And actually the second value is also wrong. 17.5. So I've got the table as it was given to me with the corresponding coordinates lined up with each other. Now after I've typed it in, all I'm going to do is I'm going to hit quadratic. We want to know the regression of this table for a quadratic, and when I hit quadratic, you'll see up in this bar it gives us our equation. Y equals, and this we can change out y for h, -4, so we know so far we're good because we both, our two equations both have the -4. X squared plus 21x plus 8. So this is our equation for the quadratic that was given to us in the table. So I'm going to go ahead and convert that over here. So we've got y equals, it was -4x squared plus 21x plus 8. And so from this equation, we know now what b is. We know that b, which is the coefficient in front of x, is 21. And we know that c equals 8. And c is our y-intercept. And we could already tell that from the first point it gave us. When x is 0, and whatever that y value is for when x is 0 is going to be our y-intercept. So we know that we've done this correctly because we can verify it with the table, and we can verify it kind of with the rule that it was given to us. Now let's go ahead and figure out if it's a maximum or a minimum value. Well, you're probably already thinking it's a maximum value because if you think about a rocket being launched up and coming down, it's going up and then coming down. So the maximum point is going to be your vertex, but let's verify using the graphing calculator. So what you would do to verify, you would just hit graphing, you would hit expressions, and then you would type in that equation that we got when we did the regression. So I typed it in already for us, and after I type it in, all I'm going to do is I'm going to open this up a little bit. I'm going to hit graph, and then I can't really see the graph, so I'm going to go ahead and zoom out. And I got to move the graph over. So I played with the graph using the trace and using the zoom features. And you can see that our quadratic has a maximum value of about 36 and it's opening down. So we can go ahead and say, okay, this quadratic has a maximum value. And now for the last part. If the rocket does not hit a tree before it hits the ground, at what time will it hit? Before or after 6 seconds? So we're going to go ahead and kind of use the graph to figure that out. So we know that we're looking for when the rocket hits the ground, and the ground is going to be the x-axis. So let's zoom in a bit to this point right here. So it starts off, shot up into the air, and then it's hitting right here, and it looks like it's hitting just before 6 seconds. But I can verify that with the table. I can go to the table and I can type in 6, and when I hit apply, if that y value is a negative, that means it has already hit the ground long before 6 seconds. Now it's somewhere down here, -10 feet, which obviously once the rocket hits the ground it can't go any lower, but on a graph it can. So we know that it's hit before 6 seconds. So we can say before, and we would type that into Schoology. Alright, example number 2. So here we have example number 2, and I'm going to do the same exact thing. I'm going to pull up the graphing calculator, and then I'm going to go to regression, and I'm going to clear this data, and then I'm going to type in the table. So I'm going to pause the video and type in the table right now. So I've typed in the values and double check to make sure I typed them in correctly. It looks like I've typed them in correctly. Now I'm going to hit quadratic. And when I hit quadratic, it gives us our equation up here. So I'm going to write that down. 19x squared plus 49.04x plus 2.96. 49.04. So 49.04x plus 2.96 plus a 19x squared. So you can see that we've got the right equation because our coefficients in front match up, and then our b here is 49.04, and our c value is 2.96. And then is it opening up or down? I want to say that it's going to have a minimum value because the number in front of x squared is positive, but I'm going to double check with the graphing calculator. So I'm going to go over here, go to expressions, clear the one that we typed in, and then I'll type in the new one. So we've got 19x squared plus 49.04x plus 2.96, and then I can hit graph. And then hit graph, we'll have to zoom out a little bit so we can see the entire quadratic. And as we zoom out, you can see that this quadratic has a minimum point for its vertex because it's opening up. So we can go ahead and select minimum, and there's no fourth part to this question. Last example for today, and it's very similar to the first one. So our first step here is to go ahead and input the table into the graphing calculator. I'm going to pause the video and I'm going to do this right now. So I've inputted the points into the table just the way they were, and now I'm going to hit quadratic. Now regressions, what they do is they take data points and they create function rules for those data points. So it's important that you hit quadratic because you want the function rule for a quadratic. If you hit linear, you would get some linear function. If you hit exponential, you'd get an exponential one, but you want the quadratic. So we'll hit quadratic, and then you can see here that the coefficient in front of x squared is the same as what the student got, and now know what B and C are, 17 and 8. So our equation here for this problem is y equals negative 4x squared plus 17x plus 8. Where B is 17 and C equals 8. But we already knew C was 8 because we've got that y-intercept in the table that was given to us. Now let's figure out if it's a maximum or minimum value. We can do that by using the graphing calculator. I'm going to type it in real quick, so I'll pause the video. Okay, I've typed it in, and I'm going to hit graph. And you can see once we hit graph, it's opening down, and the vertex in this quadratic is a maximum. It's the highest point. So we can select maximum because it's opening down. But we knew that because the coefficient in front of our x squared is a negative. The last one is if the rocket did not get caught in a tree, did it hit before or after 5 seconds? So let's go back to the graph. And it's hitting right here. It's definitely hitting before 7 seconds. But let's zoom in and see if we can get a closer view. So we're zooming in. I got to use the scroll feature, so I've got to open the window a bit. I'm going to move over, and I'm going to continue to zoom in. Zooming in. I can't know for sure. Now I can see that this line is coming down, the rocket's coming down, and hitting the ground before 5 seconds. I can verify in the table, but it's pretty clear from that graph that it's hitting before. So that's what we're doing today. We're using the regression calculator to find B and C, and then the graphing calculator to figure out the maximum or minimum, and the before or after. Good luck on the problem set.